There you go. Awesome.
Thank you.
Hey, cool. So let's get started. And we are lucky to have Gino with us today. Let's give her a short bio and let Gino take over from there. So Gino is an associate research professor at the Robotics Institute at Carnegie Mellon University. Her general research areas reside at the intersection of vision, language, and planning in robotics. Jean's current research is focused on developing high-level intelligence for robots in the domains of autonomous navigation and creativity. Her research group, the Bot Intelligence Group, includes students from diverse disciplines, including robotics, language technologies, computer science, machine learning, and mechanical engineering. Her team has won the Best Student Paper Award at the IEEE International Conference on International Robots and Systems, IROS 22, and 2 Best Paper Awards in Cognitive Robotics at ICRA in 2015 and 2018. Her works on AI Pilot and Frida Robot Painting have been featured in various media, including Aviation Today, CNET, Science Daily, The Telegraph, and CBS Pittsburgh. Jean received a PhD in Language and Information Technologies at Carnegie Mellon University, MS in Computer Science at Columbia, and BS in Biotechnology at Yonsei University in South Korea. Was it correct?
Yes.
Awesome. Thank you so much. And lucky to have Jean here. And give us a short presentation. The same rules apply. If you have questions, put them in the chat. And probably take questions at the very end, and we'll also let you unmute yourself and ask questions. So yeah, I think that's good to go and take over.
Okay, thanks for introduction and thanks for being here. So today's topic is mostly about evaluation, and I'm going to use 2 kind of different problem domains, like that one navigation example and one painting and creativity related one. And then also, okay, so and this is mostly the work done by the students and the members of the group, and then or collaborators, so including Jay and also some AirLab people here. So I'm going to kind of start with what my research group is working on. So as Jay mentioned, we are focusing on developing very high-level intelligence for robots. So not just learning and control, but something that's closer to human intelligence. It is a very ambitious goal. So it includes language understanding and use of language, how to use language to communicate with humans and then also compliance. So compliance, it can be physical compliance, the mechanical way, but also social compliance. So, and then the other 2 are more closer to, even more closer to human areas. And now the field is changing because of this new like ChatGPT and other things. So I'll talk briefly about that as well. So in case anyone's interested, there are some survey articles I can refer to for each of these topics. So in navigation, using language means how to understand and turn these directions and execute plan. And then for social navigation, social compliance, there are some papers, including some collaboration with the AirLab as well. And the survey article is, of course, it's in the process of being published in the journal. And then some recent work on creativity space. So one of the main project is on painting. And then we also do like ethical ramifications and bias issues, how to handle human emotions and so on. So there's a lot going on. And the imagination side is the area that we want to explore. And the other dots are smaller, but it's like how to make robots make fun doing things. So, okay. So related to the field, so because of these recent advances made in the area of the language model, large models, in the multimodal space, people have been wondering like where we are and what we are doing if the big companies are all producing the results. So this is kind of my interpretation of what's going on. So in a lot of like narratives or in the writing side, And also in the image space with art, people have developed this theory. There are two maybe different parts of any kind of a story. So there is the actual content, the main skeleton kind of the story, the content, or the basic functionality. And then the other side is how it's told, the style, the means, and also it has to do with the accessibility. So if we break it into those two categories and think about what ChatGPT has changed in those two aspects, then in terms of the information, think about if there is anything new that ChatGPT developed in terms of the actual information. So maybe a little bit, maybe fake news and made up stories, but it's still quite early stage. So in terms of the content, it's still built on the same data as the search engine, which is from the internet. So everyone contributed to that. So we all own a small piece of ChatGPT and all these functionalities because we made that possible. Some credits. But in terms of the actual content, it's still very new. So there is a lot to do. And I'm pretty sure within the next 5-10 years, many people will work on this space in using these powerful tools to create new things. Let me finish this. And then for the area that has been really revolutionized is this side. So how it is being accessed. So think about when internet first came up. So the huge change that the internet or the web browsing changed was before that, it's a kind of a similar thing. So the information wasn't created by the internet, but it made the accessibility more open to wider audience. So before you had to know whom to talk to, and you had to have connection to get information. But now it's more fairly accessible and kind of same thing. So maybe you can do a better job in finding information, but the ramifications are including this trust worthiness. So the source of information is a little bit unclear, so a lot of research has to be done. But anyway, regardless, this has been revolutionary. So it's these tools are very, very powerful. So we should think about how to handle these tools and use these tools for our lives. So, and then the other aspect to think about is the sim and real kind of difference. So you all know the difference between Zoom meetings and in-person meeting. So that's that one's difference. And then the virtual space AI versus real robot. So since we are in the robotics side, our space hasn't been touched much, but it's our advantage how to use these powerful tools for robotics. So the creativity and new capabilities are the areas maybe everyone should look into. And then for the real robot with the embodiment, this is the area that overlaps very well with my research group has been working on. So we are very excited. Finally, a better language model we can use. And then also dealing with the physical interaction, challenge and so on. And then this last part has to do with more robotics. So actually accomplishing precise result in the physical system or physical environment. So it's more to do with the control issues or even mechanical intelligence. So sometimes by having this very revolutionary hardware, a lot of problems are already solved. We had the conversation yesterday, like because of these hardware issues, some things are getting delayed. But I just want to give you my interpretation of what is going on and what we can do. Because there is a link, like if there is one huge success in one of these things, then it influences other things. So we should think about how to use these things. All right, so then to the main focus of this talk. So this is about the measurable part. So I think in the research side and also heavily in robotics, what we have been doing is measure what is measurable. So we come up with a clear metric and then use that to measure our success. And then today's talk is the other side. So there are a lot of things that are very hard to measure. So how do we make them measurable? And a lot of these issues come from including humans. So humans are. So this is kind of an intro. So you will know what this is. This is a cleaning robot. And whenever we design a metric to measure their performance, we need to think about what can go wrong. So some of the proposed metrics for cleaning robot is how much dust it can collect overall. But you can easily find out it can be exploited, because if this is the only objective, robot can quickly learn, okay, I'm going to just collect some, dump it out, collect them again. So the total number is high, but the job is not getting done. And then similarly, the area cover. We can cover entire space very efficiently without. So a lot of things can be proposed, but all these metrics, whatever, how hard, no matter how hard we try, every metric can be exploited. And then this is the trap sometimes researchers get into. So we get trapped in our test bed, in the data set evaluation challenge without actually solving the real problem. So whenever you are doing your evaluation for your research, just remember, be careful what you wish for, because what you get is what you ask for. And the system is just given the objective and then try to do their best. So it's the fault is on the designer. So we just need to understand what is going on to fix this problem. Okay. And then optimal solution. We always see optimality guaranteed, but it is always optimal only according to some objectives. So I'll first use the social navigation as an example. I don't know how familiar this group is on this problem, so I will just give a very high level. So a lot of self-driving robotics technologies were in fact developed in this static environment setting, meaning that the robot is the only moving unit. Everything is static, but it is still a challenge because the environment is very complex, and understanding what is traversable and what is not was very difficult. So a lot of research was focused on detecting and opening. So I think that's also used for a lot of aviation projects. So it's kind of passive approach, but that was the main focus. But in reality, we all know the environment is very, very dynamic. So there are kind of moving objects. And if in this example, you will see these are mostly humans or human-driven vehicles. So these are not just like physical objects that are moving, but humans. Okay? And then if we look at the scene a little bit longer, then there are even other things that's not really visible, or you cannot really sense from the environment, but there are human-defined rules. So everyone goes to the right, or This is okay, example, it's a little bit hard, but still you see some patterns. And those are only detectable if you look at the scene for a long time and look at the moving paths. So those are kind of the elements that are making this social robot navigation very difficult. And then even in this space, the main objective hasn't been really changed much. So it was detect and track because they are moving, and then let's avoid the collision. So those were the main objectives. And then the more recent ideas that I'm going to suggest the people to work on is more proactive. And by the way, this proactive coordination or the implicit coordination, these ideas are not new. These have been studied in game theory community or multi-agent systems. There are existing research that your work can build on. So it's about a time that maybe the communities should be collaborating. Okay. So the huge research question in social urban navigation is how can we make the autonomous agent navigate seamlessly with other vehicles, other agents in very complex environment. So it's difficult. Okay. So this is an earlier demo that we did together with AirLab. So this was just quickly show an example. There's Ian, AirLab. So we did a very simple scenario where two aircraft are trying to land at the same time. So what Ian is doing here is to communicate his intent to land at a certain runway with anyone around that space. So it's broadcast message. And then AI is trying to do the same. So after it decides where to go and how it is going to do, also shares. So it includes a lot of different challenges. So this part illustrates the visual detection and tracking challenges. But look what kind of informations are used by the AI to make these high-level decisions. So there is information coming from the visual tracking and information. So trajectory-based prediction. But at the same time, we also want to use this language understanding whenever possible. But this part still remains very difficult. So this kind of illustrates one example of the social urban navigation. And same exact problem exists, not just in the area space, but like the self-driving and also like pedestrian space. Okay, so just like to highlight the differences between just random objects and humans. So what are the main differences between you're kind of climbing the mountain and there are rocks falling down, we need to maybe track and avoid. So if they are non-human objects, there is a field called physics. So it's a very heavily studied field. So we know some things about how, how things go. But on the human side, I mean, we also follow some of the laws of the physics, but there is more than that. So I'll start with the negative side. Humans are very inconsistent and they lie. They sometimes are aggressive, they're rude, sometimes too timid. It's very hard to work with. So same thing. So whenever a robot has to navigate in human space, robot has to deal with all of this. So it's very difficult. But there is the other side, which is also very hard to explain. Like, why do people help other people? It's not their main objective. Right? So if you are driving to go to the airport, you still yield to other people to go first. That has nothing to do with your main objectives. But there are some things that people do for being nice. And we want to understand that side as well as the other side as well. Okay? So the coordination, like increasing coordination and cooperation, helping, supporting, and there is a reason, in fact, because people reason for the long-term expected. It's not like immediately, okay, if I yelled, you will back, like directly, but people have this vague belief. So if I'm nice to other people, maybe far in the future, other people will be nice to me or my children or the next generation. So even people sometimes even sacrifice. So these are very hard to understand, but we understand because we are. Okay, so that's the social navigation challenges that we have to deal with. And then this is another kind of decomposition of what has been done in the research side. So some of the related tasks are prediction tasks, trajectory prediction, which is not navigation algorithms, but still useful. Okay. And then there is pure navigation without understanding of social interaction. So that kind of build the basis for this self-driving industry. And then the social navigation is the dynamic side that we are. Again, doing too slow, so I try to go fast, but you can maybe look at the differences. But the huge open area is the combination of all. So the secret that only people who work on social navigation knows is in the social navigation community, a lot of cases, static obstacles are simple. So there are no obstacles. It's okay in aviation because free airspace, but on the ground that is not. Yes, but there's somehow the two communities were divided. So anyone can deal both the static and dynamic obstacles at the same time, and then also reason about the social interaction. That's a real problem. So for time purpose, maybe I'll skip to the, because I want to discuss the evaluation challenge part. So in the trajectory prediction, and so especially, a lot of work has been done. So this slide and so for trajectory prediction side, this slide is very outdated, so it's up to 2020, so all the papers are outdated, but that indicates the issue. So as I mentioned earlier, people are trapped within this evaluation paradigm that we developed. A lot of people use a very small set of these popular data sets because you need that result, because reviewers say, hey, did you evaluate on this? So everyone is using the same set, using very limited evaluation metrics that's measuring the difference between the reporting and the prediction. And all the values are very close to each other. Or the algorithms are maybe making incremental progress, but still, even this year, there are multiple papers being published. So I don't know about you, but I think this is the problem. So the performance is reaching into saturation, but I don't think the real problem has been solved. So we want to kind of look at different approaches to actually address these issues. And there is a reason why people are not really doing the real evaluations. We skip to because it's especially when we go to the navigation side, like social navigation includes people. So let's do the real evaluation, like include the people to have the robot navigate among people. And that's very, very painful. And we tried as well. But as you can see in some of these videos, I don't think it's insane. So it's the people who are participating in this study, their behavior, I don't know if it's natural enough to be considered meaningful. And also, people are just so adaptive and they care for safety. So all the metrics results are awesome because there were no collision, people kept like distance. So on average, they did an awesome job, but maybe half of the job was done by the people. And also another interesting thing that we just learned as a serendipity is the shape of the robot or the sound the robot makes matter more. Because if the robot looks scary, people are even more careful with that. So, and then the other side is if the robot looks cute, they think it's safe. So people are that, not that intelligent. So yeah, so how can we improve this evaluation? So we just went through kind of painful another human user study experience for the aviation project. And everyone now knows in that project, at least to understand the difficulty and the challenge. And that's pretty much the only way to say something about the performance of our proposed approach. And then the patterns were very, very thin because we can only recruit so many pilots. Pilots are not as easy as just random clinical trials. So it was a difficult study. So the proposed idea, like to going through that imagination space is, can we actually come up with a simulation environment that can simulate human-like behaviors? So again, this has been tried, but none of the existing simulation environments can simulate human behavior. Because if we already have it, problem was already solved. So it's chicken and egg, but we have some idea and had a very recently similar idea was published in one of the papers, but I don't think it's identical idea. But the proposed idea is, can we come up with a population that shares some statistical properties? And then the question is, what kind of statistics will matter in this case? So we have some ideas. So we collected a bunch of different metrics that have been used in human study, psychology, cognitive science, and robotics to gather some of the values from the real human data. And then we collected the data. And then the finding is the statistics vary a lot across even human data sets. So it's expected, right? People are always behaving differently depending on environmental context. Okay, no surprise. And then we also evaluated a lot of existing algorithms to see if there's any match. And another one, so there's no clear winner, but some metrics we see correlation. So this algorithm in this category is very similar to maybe PhD lesson. Okay, and then this is also another kind of we knew, but confirms. So in the popular metric that's used like ADFD, which is displacement error metric, they're all close ties, but their actual behaviors are very different. So when we did the tournament, so like in algorithm, just in self-play is like everyone uses the same algorithm, and we also did the tournament. So what this reveals is some algorithm can be exploited by another algorithm, but that algorithm can be exploited by yet another third algorithm. So there is some hierarchical structure, and we can actually play with a lot of this different composition. So I think in social urban navigation, we should think about this kind of new way to evaluate our work, because going through this human study every time is very difficult. So anything that we can find and make that connection. So these metrics correlate well with how people evaluate on certain categories, and that's a connection. Okay. Then I can show just briefly about the link between navigation problems and the painting, because people think that they are very, very different, but to me, they are the same problem. So in navigation, I mentioned the direction following, which is taking language as an input and then generate a sequence of actions. So it's a planning problem. And then in between, the robot has to use perception to align the language together with the map and the current. So this kind of illustrates, so there is a language, and then here's our robot. And in this example, even if the robot is blind, like no visual sensing, you can still imagine what needs to be done, because the language gives a clear dimension. So you can actually imagine the space based on this description. Okay, there must be some car, and then I need to go to another building. That's but using vision, you actually contextualize that understanding. So aligning the two to actually come up with a plan to the. And this exact same thing happens for the painting. So we take language as an input. So, okay, Albert Einstein is dancing. And when you hear this sentence, you can visualize what is it, what can be painted. That's the process that's happening. And then what the robot actually needs to do is turning that into this visual understanding, what's happening on the actual canvas together with planning. So the action space in this case is the set of brush strokes. So instead of taking steps, it's kind of adding one brush stroke at a time. So exact same rule. Agree? Okay. So so the painting, so this showing the robot that's doing the painting here. And the goal of this project is, in fact, we want to use Frida. Frida kind of is an initiative. So we want to use robotics for developing arts. And the whole, the ultimate goal is to help human creativity. So we want to support different modalities to interact with it. So natural language understanding, sample images, even sound, and maybe even gesture or facial expressions. That's our focus. So eventually what we want to say as kind of the conclusion of this project is robots can actually make people happier by doing this painting together or sculpting together. But how do we evaluate that? That's again difficult. So the two projects share that pain together. How to evaluate what we okay. So you have seen some paintings on the wall. So the big question is, how do we evaluate? So we go through the exact same thing, like on some user study, and then there are some consensus on these things. So that's what has been done. And then to understand this space a little better, in fact, we organized several workshops to collect ideas. So I'm going to share very briefly the result from these multiple meetings. So what we did was we asked, we showed some of these paintings or artwork to the participants, and then they were asked to come up with a set of elements, what defines, what constitutes creativity or the quality of these art. So, and then the results were all over, but I managed to summarize that into 4 categories. So first one is the contextualizing. So whenever this is very similar to how the researchers do this. So whenever they see a new work, then they want to see where it fits. Right? Is it similar to the existing work? What's the novelty? Right? What is the original idea here? So what's new? Is there any new value added? But within the things that they already know. So this is maybe this is the part that we can actually develop metrics because there are anomaly detection, there are similar concepts. So let's skip to the next part. And these two are the next two are too subjective because these are more individual. When I saw this, I felt sad or very personal experience together with the reaction. So these concepts I would just skip. And then this another one is seeing everything as part of a larger process. So this is how people perceive me. So they don't just judge given one piece and just laser focus on that. They try to still see what can happen afterwards. So they actually see beyond the. So that's a human way. So there are some theories that from other fields were discussed, but these are hard to use for metrics. And the last one, it sounds more difficult to come up with metrics. So these human values are human defined values. So similar to the social norms or the human defined rules that are invisible, but it's there. Like diversity. People care about humanity, uniqueness. So these are important things, but this is very vague and not directly visible or perceived using maybe simple sensing. It's difficult, but to me, maybe the human value part may be measurable. Can you guess why? There is one example of the human values that we use every day. That's a number. Money. Yeah, money is so if anything that can be translated into some money, like price, we can do something about it. So luckily there are the fields like finance, economists, they have been studying this for a long time. So they're very good. Okay, so I'll just stop there. So it was a very, very quick summary of the multiple things, but hopefully there was something interesting to. Okay, stop there and then maybe we'll take any questions.
I have a question. The part of the evaluation is very interesting. And actually, we are facing the same issue for optimal driving tasks as well, like how to evaluate in terms of the driving performance. Because there are a lot of ways to drive optimal, like there's no optimal solution, no optimal trajectory. From that reminds me another kind of line of work in the inverse learning. We're trying to recover the underlying reward function from human behavior, human demonstration. So, and they are trying to use that reward to come up with a better policy, like policy, like to maximize that reward function. So, yeah, I wonder, do you have any idea, like to use their machine learning algorithm to come up with to solve this evaluation problem, like use a learning based method to learn like what's the underlying evaluation metric or reward function that human use to evaluate.
I'm glad you brought that up. So like something like an intrinsic motivation, like Deepak's word, curiosity.
Yeah.
So we also want to kind of work on that space. So that is like another one that's kind of very, very new idea. So we want to come up with something like some representation for having fun. So it's similar, but it's different from curiosity. But if you are having fun, maybe you can spend more time to make it happen. So we are going to use that idea for the sculpting project. So we will have the robot just play with the Play-Doh, and then eventually the robot should be able to learn from one 3D structure to another shape. So shape to shape project is what AirLab has been looking into. But the whole motivation, there is no like clear goal, like you have to make the triangle shape. It's just have fun and play with how to make the robot play and play safely. So without hurting itself, but still learn something. I don't know.
Oh yeah, I can probably ask a question. So, I guess like language instructions from humans are always not very clear. Sometimes they can be ambiguous. So, have you thought about like if you have ambiguous instructions or like conversations between humans, like how would the robot will deal with that kind of ambiguity?
It's just there. So, I mean, whatever I say can be interpreted in even simple saying like yes. Did I say yes? Doesn't mean yes. So there is many interpretations. So they have to just learn how people use language to communicate. So it is not like one-on-one mapping to mean like only one thing, but it can mean many things. But that's how people use that medium, language representation, to communicate and negotiate. And it's not like super efficient, but that's a skill. So speaking one language is different from the general communications. So writing ChatGPT is kind of revolutionizing that space. So it's making things a little bit easier for people who are lacking communication. They can use because everyone has ideas, like good ideas, but only those who can communicate better will move to the next level. And maybe some of this development will reflect in that part. And then that also helps like direction governance. So the recent paper actually is an AirLab graduate, Rosario. What his team has tried was give a high level command, give it to ChatGPT, and then come up with a broken down, like the simple commands. But you can actually tell ChatGPT, okay, use only these primitives, because we only understand this. Then it can spit out that you're only using the primitives given, and then actually achieving the high level goal. So what human engineers did was implementing each primitive. So then, all together, you're kind of connecting the dots. And that's how the older classical language understanding was implemented. So, but this ChatGPT part was like using machine learning, instance-based learning, cognitive models. Many things have been tried without much success. So yeah, maybe this can be used. So, but ambiguity always exists. So in this pipeline, no ambiguity because the intermediate language is structured. So like robot understand the rules. So, yeah.
Thank you.
Any other questions?
I can go next. Only going in a circle in this part. I know you, and this is kind of segueing into your last answer on ChatGPT and these emergence. Last few weeks, we have seen almost an explosion in creative AI, and your work is kind of pretty similar. And I know you start off the talk, you mentioned that it's companies doing this. It's not research lab, it's not independent groups. I was wondering if you have some comments on how those companies are doing the state evaluations. Are we evaluating these models enough? Or how does kind of the academia industry thing kind of fit into this whole new landscape of these large language models?
So the model itself, there are certain things that we can measure, the fluency, the metrics that NLP people have been using, like the score things. I think on those metrics, like they will probably just doing very, very well because very fluent, and you will just, I don't think ChatGPT is more fluent English than me and many other people too. So I think people now want to evaluate like the language models for other capabilities. I don't think it is a fair game, but because it became so good at answering some of these questions, people have misperception. Oh, maybe this is the ultimate AI that can have a very high level, like reasoning skill, decision making, and more than what it's capable of or designed for. So language model is the language model. Its job is predicting the next word, and it just happened to become very, very good to do more like the question answering, and sometimes it's more consistent. But you can play with the ChatGPT to actually find out what the model is capable of right now. And I'm pretty sure there will be only more improvements. But as of today, if you ask questions, something like, hey, can you ask me questions to figure out who I am? Like people can do this very easily. The ChatGPT asks, what color do you like? So these are not very smart questions, but it makes sense in the language process. And then also the like video generation. So the multiple new ideas came out like last week, but it doesn't really solve high level understanding. So the actual action. So if you ask to generate something that involves manipulation, can you maybe pour water to the cup or something like that, then it struggles because it can only generate video for a little bit lively, but still content. So it is not involving any planning and consequences or reasoning or constraints. But I think within 5 years, maybe everyone will see a much better results. But right now, it's still at an early stage. And there are plenty of research work that you can do to improve. And the other huge area to deal with, something to do with the evaluation is not just the fluency and things, but the trustworthiness and also the bias. So what we did for the stable diffusion kind of text to image generation tools. So if you look at it, it makes sense because all these models were trained on billions of examples. But look at the globe, the Earth, and then guess where all the data came from? It's a very tiny region in Earth. So it generates really nice, high quality images, but look carefully what kind of culture or what kind of people they represent. So it's fluid, but it has some limitations. And since the data is really large, even if we want to compete with this bias or misrepresentation can be difficult because that means we also need like billions of examples for these observations. But is that the only way? So the approach that people have to look into is, can we actually use very low budget, computing low resources, very few examples, can you still fight over this heavy bias trained with really a lot of. So very recent work our group did was a just very simple technique like fine tuning. And it turned out using just maybe 200 images, we were able to generate culturally relevant images. And we are trying that idea with a moment to actually have a decent conclusion. Okay, 200 is the number. So we are developing the very tiny data set. So the data set is called the count. It's the big data is called the Tartan. So,
I guess we can, we're out of time. Yeah.
okay. Thank you.
Hey, thank you so much.
At this moment.